Prove that P and negation P and P, or negation P and negation Q is a contradiction. The question here is asking us to prove that this expression on the board is a contradiction. Now, let us look at the solution step by step. Firstly, let us look at the meaning of this contradiction according to logics. By definition, contradiction is a logical incompatibility between two or more statements. Contradiction is a logical incompatibility between two or more statements. It occurs when those statements taken together yield a falsehood. It occurs when those statements taken together yield a falsehood. That is the definition of contradiction. Once we've known this, the rest will be easy. Now let's go to the next step. This is the one of the terms that is given in the question. As it is, we have it here. The name is or. We call it or. So it looks like V, it is or. True, this T stands for true, this F stands for false. True or false is equal to true. True or true is equal to true. False or false is equal to false. This is a law. We need to get it. T or F is equal to T. T or T is equal to T. F or F is equal to F. And this sign too, we have it in the question. The sign is called and. T and F is equal to F. T and T is equal to T. F and F is equal to F. This is also a law that we need to take note of. Now let's look at the terms one by one. P. We are given P in the question. We have P, we have negation P, we have Q, we have negation Q. So let's look at them one by one. P, T, T, F, F. That is true, true, false, false. That is the data for P. Now for Q, we have T, F, T, F. That is true, false, true, false. Now, negation P. This sign stands for negation. So it means opposite. So opposite of P is the same thing as negation P. So opposite of this one will be false. You have true here, false, true here, false, false here, true, false here, true. So that is false, false, true, true. Then negation Q. Negation Q. This is Q. The opposite of Q. False, true, false, true. As we have in Q, true, false, true, false. So this is the negation of Q. The next thing from the question, we are picking the terms from the question one by one. Negation P and P. Negation P and P. We want to take them together. This F and T. It gives F. That's false. F and T. F. T and F. F. T and F. F as well. So we have false, 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 false. All these things I'm saying, it is already indicated in the law here. The next thing, negation P and negation Q. Negation P and negation Q. We have negation P here, we have negation Q here. So let's take them together with the sign and. F and F, it gives F. F and T, it gives F. T and F gives F. T and T gives T. So we have false, 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 true. That is for negation P and negation Q. The next thing we have here is to take these two expressions together with the sign or. Negation P and P, or negation P and negation Q. It means these two terms, we are taking them together with the sign or. So F or F gives F. F or F gives F. F or F gives F. F or T gives T. So we have false, 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 true. It is there in the law. What we did here is indicated here in this law. So we have false, 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 true. Now, the last expression here, according to the question, according to what the question asked us, that P and negation P and P, or negation P and negation Q. Now we should prove that it is a contradiction. Now let us look at it. P and negation P and P, or negation P and negation Q. We want to show that this expression is a contradiction. What are we saying? This thing, we have to take it together with P. We are taking it together with P, and we are using the sign and. So we take P, which is TTFF. We now say and this expression we have here, FFFT. So the first term in the P, T and F, it gives F. T and F, it gives F. F and F, it gives F. Then lastly, F and T, it gives F. That is false, 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 false. So in this expression, we see that what we have all through is false. That is what the definition of contradiction is telling us, that when the result yields a falsehood, it is known to be a contradiction. Therefore, it has been proved. It has been proven that this expression given in the question is a contradiction, because we have falsehood. F, 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 F. Thank you.